Hello and welcome to the latest episode of the Trend Detection podcast. We're in a new location today. I'm really excited in the studio today, joined by my colleague, Jonathan Bonner, who's been on many times onto the podcast. Welcome back, John.
Thank you for having me.
Awesome. Today, we're talking about heavy industry and real world wins with predictive maintenance in the heavy industry. But I guess before we start, heavy industry is quite a broad term. Could mean a lot of things to lots of different people. So when I'm saying heavy industry, John, what does that mean to you? What sort of let's say sub verticals we're talking about here?
When you think of heavy industry, you can think of it in two ways. Either the machinery used in this process manufacturing are heavy, big, extremely large, the size of warehouses, tall buildings, or what they're producing is heavy, big, and large. So typically, heavy industry contains heavy stuff, makes heavy stuff. However, when you look at the sub-verticals, you're thinking of metals, mining, cement, those type of manufacturing environments.
And in terms of, I think we know across all industries, actually, predictive maintenance is becoming a strategic priority. But why specifically in heavy industry is it becoming so important?
Well, if you think about predictive maintenance, it's a decision support tool designed for maintenance personnel. But it automates the function of a condition monitoring engineer on site. So the data collection, analysis, and reporting are now automated. But like any good condition monitoring engineer, it continues to learn about failure modes, failure patterns, and can be quite precise in what it's recommending for maintenance actions and corrective actions. But it's also monitoring machines' equipment 24/7. So continuously gathering data, information about the condition of a machine. But what we're finding, or what has been a problem within heavy industry, is that without visibility of these machines' condition, they are running to failure. Now, a human being wouldn't run a race in a desert without water, without support, without medical advice or check-ins. And this is actually, if we use that analogy, what maintenance teams in heavy industries have been doing, running to failure. But with predictive maintenance, it gives them insight into the condition, into the signs of degradation, so that a specialist like a doctor can tell you when to slow down, when to hydrate, when to rest and recover, or perform maintenance in this case. So really extremely important in all industries, but specifically in heavy industry.
So why is running to failure so common in heavy industry? What's sort of brought that mindset on, if it is a mindset thing? Or a cultural thing?
I wouldn't say it's a mindset or a cultural thing. I think it's got to do with availability of time, resources, skills, knowledge about what's happening, or visibility of what's happening. Quite often, environments such as heavy industry, your metals and mining, have been set up with visibility on the process, what product is coming out, at what rate, and at what quality. But very little thought has gone into the maintenance or understanding the condition of these machines. So you'll find that often data is there, the ability to have visibility is there. However, it's just not catered for in the initial designs or the initial operations. And now after 20, 30 years of running, they've done it in a reactive way, day in, day out for decades. And they haven't had a reason to change. Whereas technology nowadays enables this change.
And you mentioned about data before, and there's obviously, again, across all industries, but in heavy industry as well, there's, data is being collected. But are you saying maybe it's not being utilized in the right way at the moment? It's not being explored. The insights aren't being gathered from that data.
Absolutely. So at the moment, what we see is it's a lot of the data that exists on a site is geared for process control or understanding of production. Perfect. That has huge amounts of benefits, and that's great. But what you need, especially for predictive maintenance, is condition data. So condition monitoring data such as pressure, current, torque, vibration, temperature, speed, flow, cycle time, whatever is relevant to identify the normal condition of an asset. Now, some of those are available within PLCs, drives, inverters from a customer's environment existing already, but a lot of them haven't been mapped in. So there is no record or historian of this data, and there's no analytics being employed on this data to gain further insight. But that's where predictive maintenance comes in. It's about using your existing data along with additional data that can either be mapped through your OT environment or supplemented with additional sensors so that you can get a centralized visibility of an entire plant's production, the signs of degradation, with then recommendations on what maintenance should be done, when it should be done, and even who should be doing it.
No, exactly. And I guess to your point as well, because we do like to say, use existing data where possible. When there is a requirement to, add additional sensors and bring in other types of data, I mean, I can only imagine in a heavy industry environment that's quite challenging. That's a question for you, John, actually, is about, is it challenging to collect data in such a sort of a rough, potentially rough environment?
Actually, no.
No, I suppose.
Actually, no, yeah.
Misconception here.
No, but although it hasn't been mapped through, the data exists. The systems are in place already that are gathering the data, which are controlling the machines and that have these forms of data in it. So the data we find exists. It's there. It's really about how to access it. And some of the challenges we're finding with that is really around how a company has grown. Or let's take a steel plant, for example. A steel factory could have many different plants inside of it. They could be different ages. They could have different OEMs responsible, different controllers, different communication pathways. So really, getting access to the data can be a bit of a challenge and has been a challenge. But we do live in an age where gateways and getting access to the relevant data is actually relatively easy. There are single devices that can speak to a range of OEMs, can gather the relevant data, can do the data processing that is required, and can push it to the cloud in a very secure way, practically risk-free. For a small adjustment, huge amounts of value. And in heavy industry, the data that is existing already, it's there. And what we're finding is the addition of additional sensors and hardware is actually not as much as customers would think to get started. So we can drive a lot of value from existing data, existing infrastructure that is already there.
Yeah, I guess is it one of those things where sometimes there's a underestimating the value within existing data already, and maybe the other way around as well, so overestimating the value in data. Is that something that you often come across, those very contrasting scenarios?
I think the scenario that we come across the most is overestimating the data that is available. Quite often in our investigations, customers say, yeah, we've got plenty of data, loads of data, no problem there. And then when we come down to actually investigating what they have, as far as time series data, continuous measurements of a parameter, like current, like torque, and so on, that isn't necessarily in place. Again, they'll have a lot of process-related data, not necessarily condition data. However, there is an underestimation of how much value can be derived from what is existing on site. So when we really do start to investigate it and we look at the possibilities for additional data mapping, for adding in a data gateway that can speak to OEMs, controllers, and make the data useful, really we have a lot of value and a lot of benefit from that existing data already. So part of my role within Siemens and Senseye is to assist with those investigations, to help identify what data exists, where does it exist, how do we get access to it, and how can we process it and get it pushed to the cloud so that we can use it.
Well, I guess another angle on this as well, because we talked a lot about data and collection of data, but the other side of it is the human element, the knowledge that's often locked in people's heads or in manuals and things like that. And so how, in the heavy industry, how can they extract that sort of information out and utilize it in a sort of a predictive maintenance deployment?
I guess that expert knowledge comes in a range of forms. The first form, and which is actually being extremely useful for us now, is expert documentation, OEM manuals, maintenance manuals, decision trees based off of experience over many years, written documentation on machines, what to do next, problem shooting and so on, troubleshooting rather. So we can load that into the application, and that can be used and referenced directly using our Senseye Maintenance Copilot. But the other form of knowledge and experience that we want to capture, or at least feed into the application, is the human knowledge, the stuff that is inside of their brains, the stuff that has taken decades and decades to learn. And that comes in the form, well, at least for us, in maintenance event information, tracking what was done, what the problem was, what their process of fault finding showed, who was involved, tracking and making markers of their knowledge inside of the application. So using documented knowledge and the person's actual actions and feedback of their actions to unify that so that it can be so that it can be referenced ongoing in the future.
And I wonder, in just the technology context, we know how valuable, knowledge people who know the machines like the back of their hand, have worked in the industry for a long time. But when it comes to a technology deployment, is it sometimes forgotten that actually your knowledge is just as important to this as, the data we collect from machines or how well the technology works, if that makes sense?
Yeah, so the specialists on site who can help give us access to the data, can help us process the data. Having that specialist knowledge and input from the very early stages means that when we run into the initial deployment, the start of the project, that everything has been considered well, that we've had a smooth implementation, that the onboarding process has gone well, and the results that we're getting are really good because we've taken everything which is important, which can only be found out from the specialists on site, the people who have the knowledge and know-how and experience they bring into a project is just phenomenal.
And I guess that leads to a more general point about, workforce engagement in the project and the change management required for a successful rollout. Because we know you were just saying then about, you need people engaged in the project in order for it to work, or, people engaging with the app and looking at cases and things like that. But maybe you could talk a little bit, Jonathan, about the change management piece. What mindset needs to sort of change within an organization?
Absolutely. Without people adopting the solution, without them using it, it's useless. Doesn't matter how good the functionality is, doesn't matter how impressive the features are. Without people using it, it is useless. So we have a number of ways of addressing this. The first is to get the right people in the room at the right time, early on. So when we start a project, there's typically 5 key characters that we look to involve. Project sponsor, someone who at a high level can enforce change. They can get you the budget and the PO that you need. They can get replacements for anyone who goes off sick in the project. High level change, project sponsor. Then we're looking for maintenance representation because ideally maintenance personnel are our desired end user. So we want them involved as early as possible so that it's their solution, not something that management has done and now expects them to use. We're looking for a PDM champion, someone who is going to be responsible for day-to-day progress and moving the project along. We look for controls or controls and drives engineers, OT staff, people who can help us with the OT environment, and then IT, essentially because we need the data to move from the OT environment and come into the IT space in the cloud. So having the right people in the room at the right time is absolutely key. But you also need to get them on board. You need to make sure that their concerns are addressed, that they are completely satisfied and happy, and that they become, every one of those people actually become your PDM champion because they can progress it along during the initial stages, but also act as your champion throughout their business. They can take the results and distribute it internally and get other people excited so that it's more widely used and more widely adopted. And really what we want by that is to have other departments, other plants, other factories and other locations begging to have the solution implemented because of the good stuff that they're hearing from Site A.
And you mentioned that, about scale as well, because of course, predictive maintenance across a line, across a few machines is one thing, but across the real value and return on investment, as we know, comes from scale across multiple plants. But what are sort of the challenges, again, thinking about heavy industry, probably very remote environments? How tricky is it to, scale predictive maintenance across those environments?
Scale is not actually that much of a problem. The machines are there. Typically, the infrastructure is there. With some small adjustments, even for remote plants, you can get connectivity, so we can still get access to the data. So the ability to scale is not the problem. It's about targeting the use case, the value, the business outcomes that drive scale. because you're working with a project team. They know the ins and outs of the solution you're proposing. They're all happy with it, but they all need to go and present these results or the possibilities to a higher team. And once you're running the project, they need to advocate for it and push those results again to the higher team to get further buy-in, to get further financial support to scale. So I would say one of the biggest challenges is really starting a project that is going to drive business value, that's going to drive return of investment, and then making sure that you are targeting everyone's concerns, their desired outcomes, so that you're running the project successfully, that you're constantly checking on milestones, making sure you're hitting the success criteria at the right milestones, so that when you do come towards the end of a project, as I said, people are dying for a scaled operation, not just, that was nice, but we'll try again in a few years.
Exactly. And it's all got me thinking about who leads these projects. And maybe it's not, it probably differs organisation to organisation, but from your experience in heavy industries, is it, do you find these are sort of IT-led initiatives or more on the sort of the maintenance engineering side, or is it really, both coming together and meeting in the middle somehow?
Absolute mixed bag. Within heavy industries, we've engaged with maintenance teams, digitization teams, IT teams, a full range of teams, I guess, but a full range of them who are interested in predictive maintenance. But all of them have different reasons for investigating predictive maintenance. So maintenance team looking for a maintenance efficiency. Fantastic. That's what predictive maintenance is about. Digitization teams. Yeah, sometimes digitization teams can come about because they were at a show, an event. They saw something really cool. Now they want to investigate it, see if it can make change. Other digitization teams have a very clear use case. Fantastic. We like the ones with a very clear use case. IT teams are typically more cautious of the digitization in a sense that if you look at the risks in integrating OT and IT, or the perceived risks rather, that is quite high. And what happens if it fails is also quite bad. The risk of failure is extremely high. And no one wants to start something with that amount of risk. So IT teams can be a little bit tricky. However, when we start to really engage with them, speak their language, identify what is important to them, and what risks they feel, we can then start to mitigate those and make them a lot more comfortable with the project. But typically, we're wanting to work with maintenance, digitization, those type of characters, because typically speaking, their objectives align with what the deliverables are with predictive maintenance.
Yeah, it's interesting because you mentioned objectives and outcomes, and that's of course why we're here, is to deliver the outcomes and overcome the challenges customers are facing. And I know we could talk about unplanned downtime and reducing maintenance costs and being more efficient. But I guess one which I think is probably particularly interesting, well, particularly important in any industry, but in heavy industry particularly, is safety and workforce safety. And I remember speaking to a guy on your team, Tom, a colleague of ours, who was saying he spoke to a customer who actually brought that to his attention. When they're talking about, what challenges are you facing? Is it downtime? Is it? And then he was like, no, safety, which we all know is the number one priority. Yeah. But again, maybe you could talk about predictive maintenance, role in that, which can play such an important role in that side of things.
Absolutely. So if I just run through some of the benefits of predictive maintenance, reduction of unplanned downtime, right? That's the obvious one. But also precise and correct maintenance. So really knowing that for the 95% of your operations that are in perfect health, that they are in perfect health, don't touch them. And that then drives the rest of the benefits, or a full range of them, one of them being safety. Because the less you have to touch a machine, the less risk and more cost there is. So you don't have to send people out to go and do inspections because you have visibility of it. You don't need to do planned maintenance, or you can reduce your planned maintenance rather, because you have visibility of an asset's condition. You can have better planning time. You can make sure that you have the right spares, the right people when production allows. You can make better informed decisions. So huge impact on safety in that sense. Also, having a more reliable operation, more reliable machinery, um, is going to have a safe, is going to give you a safer environment, because now you're not having, rather, the risk of something going wrong is a lot less because you know what the condition is. You're not running to failure, where failure could mean massive parts snap, break, essentially explode because of pressures and temperatures and so on. You've been able to understand the condition, do small little changes so that your machines are a lot more reliable and therefore more safe.
Yeah. So like I said, because it's unexpected as well. You could have someone just standing next to a machine, all of a sudden, if you know what's happening with that machine, you're monitoring that machine, and you know that machines are flagged to you that potentially, need some attention, then you can plan that much better.
Yeah, absolutely. And with heavy industries, you don't get many chances at safety.
No.
Because, as I said, big machinery, big products. When something goes wrong, it goes wrong in a spectacular way. I've been privileged enough to work in a wide range of factories and industries all over the world. And I've only seen it go wrong a few times, but when it happens, it's extremely scary and extremely dangerous. If you look at in certain areas, let's say that have an ATEX requirement, so they are hazardous for explosions, when something goes wrong, it goes wrong very, very badly. Environments, even an environment that just has dust, powders, sugars in the air, can cause massive explosion risks. And when it does go up, it goes up in a huge ball of fire, really. And anyone who's sitting or standing or around that anywhere close is in massive risk of fatal injury because of that. And that's just one example. In a heavy industry environment, there are millions of things that could go wrong and millions of things that could be fatally damaging, really.
No, exactly. And I really liked how you sort of articulated how, throughout all the outcomes we usually talk about, they actually lead to, the end goal, of a safe working environment for maintenance people, which it was fantastic. So I just want to shift gears and talk a little bit about return on investment and within heavy industry. And I know, knowing our customers, we've seen lots of successes. We could maybe talk through some of that as well. How quickly, organizations should expect to see a return on investment maybe in heavy industry as well. And of course, we've got many successful customers, but BlueScope Steel is one that sticks in my mind because I've spoken to them quite a few podcast episodes to look out for. And we might even link to them in the show notes as well. But yeah, so return on investment, what does that look like from a heavy industry point of view?
Well, for us to calculate return on investment or even project what a return on investment can be, there's a number of factors we look at. The first is the cost of downtime. So this could be production loss, again, heavy industry, big products. That could be tens of thousands, hundreds of thousands, millions an hour. So an hour loss of production could cost you quite a lot. Then there is the breakdown cost, the actual machinery which has failed. Is it a simple component replacement? Do you have to replace the whole thing? Is it a specialized machine that you need to get shipped in, or that has a 12-month lead time? All with costs involved or associated with those. There's also planned maintenance efficiency, so a reduction in your scheduled calendar events. And then there's a reduction in spares used during various maintenance types. So that's how we look at driving value and return on investment. But with heavy industry, because, again, heavy machines, heavy products, just saving one event can have huge impact and definitely ROI. So one of the fastest ROIs that I remember looking at from Siemens Sensei is it happened over 2 weeks after the deployment. So within 2 weeks, they had a return on investment from one event. So it just so happened it took 2 weeks before something interesting happened and we were able to notify and get resolved. But it was one event that saved millions of euros. Heavy industry, one event could be life-changing, essentially, when you start to look at return on investments. But typically when we're calculating the potential, we're trying to project what return on investment can be. We're looking to have that anywhere between 6 and 8 months. maximum 12 months. And the way that we do that is to target the value. So yes, in certain circumstances, that is looking at the critical equipment, the ones that if something were to go down, it would have huge financial impact. We would want to monitor those, but also the ones that are having impact because of lack of reliability. So ones that are causing you unplanned downtime events, that are stopping production, that are halting your process of making stuff that makes your company money. So that's how we would do it. But typically, we would expect it to be months to achieve our ROI. And I believe with some of our heavier clients, within the first year, you're looking at about a 10 times ROI, typically speaking.
Yeah, it's amazing. Yeah, it's like I said, I mean, we haven't talked about it too much, but in terms of even like production stopping, if you're not making material, then you're not making money, right? And that's such a key aspect of it.
Yeah,
keeping things running.
Absolutely. And also, if you look at the metals environment, if you have a stop at some point in the production or processing of it, you could have scrap that needs to be reworked, or actually just scrap. And in certain circumstances, I remember a customer of ours, we gave them a notification which allowed them to do a simple adjustment on rollers, just got metal running through it. They did a simple adjustment and they saved, I believe it was 20 kilometers of sheet metal. One notification.
Wow.
Yeah. So there's lots of factors where value can be derived with predictive maintenance, but unplanned downtime, reducing that, reducing planned maintenance, reducing your scrap and rework, and reducing spares all go to drive a tidy profit, return of investment anyway.
And I think, again, something you referred to earlier is about capturing these successes as well and sharing them internally, because there's nothing more, look what this has just saved, how much money this has saved. I mean, everyone loves a good win story, right?
Yeah.
So,
and that's why we have the ability to capture those metrics in the application. Carbon saved, downtime avoided, scrap, rework saved, machine parts saved, and so on. We can capture all of those. But with our customer success department, we also go through a hefty process of capturing the wins, taking the maintenance events that have been added in, speaking to the people who have captured these, creating slides, creating material, creating these playbooks so that the customer themselves can use this internally to say, hey, this project we've been running? Well, look at how good it's been. Look at all of these in-depth successes that have absolutely saved us money, time, and made us a lot more efficient.
Yeah, and of course it's a key part of the, and it's also a key part of that scale process, because you could go to each site and say, well, look at the successes we've had over here. That old fear of missing out type concept, right?
Absolutely. We try not play sites against each other.
No,
but it does work in our advantage every now and then. Healthy competition.
Well, it is. It's like, yeah, I completely understand that, because everyone wants to see, oh, you're seeing success. Maybe we could see the same success, and it just builds that momentum internally. I mean, maybe we could talk about that actually in terms of momentum behind a project. I mean, I guess that's important as well. Keep the wins coming through, keep the engagement coming through, and it's sort of a self-fulfilling prophecy. If it the momentum's there, the wins are there, it's only going to grow, build momentum, scale, etc.
Yeah, absolutely. And that's why we make sure we have the right people. We make sure that we're targeting value and that we're capturing the success, because you need to keep the momentum going. Any digitization project, specifically PDM, it doesn't just happen overnight. It's not like you install some sensors and boom, it's done. It is a full process. It can take weeks and months to investigate, implement, get data integrations together, get people trained using it. It's a very iterative process of getting the customer involved, engaged, getting it set up, getting them using it, and then driving success. At least just trying to get the users to capture the success. But we do that continuously. We're there to support our customers continuously because of that momentum. We don't want anyone to get frustrated or disheartened because it's taking longer than they expected, and they just want to give it up now. We want to keep that momentum going. And yes, there are hurdles, but hurdles aren't a problem. You can jump straight over them and keep the momentum going as long as you're there to support the customer. And that's what we do.
And I guess because we haven't touched upon sort of AI and well, Gen AI, obviously, and Copilots are a huge topic at the moment. But how are they sort of helping with adoption within heavy industries? And and again, the point I was originally going to make actually is, when people hear AI, they think, oh, turn it on, it's magic, and off it goes, kind of thing. So we could talk a little bit about that, but I'm more interested in sort of how that's helping to people to understand these technologies and use them in the right way to get results.
To be honest, it's been absolutely amazing. First of all, it's making the information which really you should have had, or you required some sort of condition monitoring data analytics experience for. It's making that information accessible to everyone, because now you don't need to understand the measures, what the measures mean, what the patterns mean, that there is a pattern. This information is being presented to you in your natural language. With the Sensei Copilot, it's also then making recommendations based off of the measure, what the measure is doing. It has that condition monitoring, reliability, maintenance knowledge inherently embedded within it. So it's understanding the data from a condition monitoring perspective, can make recommendations, and then still use all of your historic events, maintenance events, notes, feedbacks, case closures, and can bring that past experience into the present case. So it is acting like a reliability or condition monitoring engineer who knows this machine from the moment it was onboarded, every bit of data, every pattern, every maintenance event, and can make or bring that information to the user as it relates to what is happening now. But with our Copilot, we can then add in the expert knowledge, the documentation I was talking about earlier. So you can upload these and pretty much instantly have reference or have access to this information just by asking. So with a few prompts, you have access to the user manual, the maintenance manuals, the spare parts lists. So if you want to find out what the code is for a drive end bearing, just ask it. It's there. And it can reference this information and make it available to everyone. And because it works in every language, it helps global organizations to collaborate. It doesn't matter what language the manual's in. Is it in Cantonese? Is it in German? Doesn't matter. You can speak to it and reference it in your natural language. Fantastic. But it also makes maintenance teams around the world, or gives them the ability to collaborate, because again, you can speak your natural language, and the Copilot is continuously learning from all of these events, from the knowledge, from the conversations, from the users and the experts you have on site. It is learning from them. And when you have a global organization set up, it is then benefiting everyone.
And I guess we could also, because we're taking, the products, it's come a long way over the past, 4 years I've been with Sensei, now Siemens, but in the past sort of 12 to 18 months, it's really accelerated. And particularly, it's interesting you mentioned the collaboration piece as well, because not only is the Copilot enabling that, we've also got things like app mentions coming into the app now, where you can just bring someone into the loop. You can upload a picture and say, oh, look at this, I saw this. And you can say that to your mate, your colleague all the way on the other side of the world. So connecting these colleagues together.
Absolutely, yeah. It's becoming a lot more about collaboration. A few years ago, it was about machine learning. What is the machine doing? Understanding the data, the condition monitoring part of it, let's say, or the automation of that at least. But now with the Copilots, with our in-app mentions, it is about collaboration. It's about learning from a lot more than time series data. It's taking in many more inputs. As I've said, your documentation, maintenance event information, human feedback, conversations that you're having. So now me and you working on the same problem, even if we are continents apart, we can collaborate on this, and it's all being there, stored and being used in the future when it's relevant and necessary.
And not only stored, but again, it can be raised again in future. So people leave organizations or move to different roles. The knowledge is still there. Yeah. All it takes is someone to ask the question again. Oh yeah, we had this previous case, and then comparing to previous cases.
Yeah. Well, honestly, every environment that I've been in, every single one, they've all had that. Dave Dave's been there for 30 years. He knows the machines. He can walk around and hear when something's off. He can put his, screwdriver to the ear and listen and go, yeah, okay, this is a bearing going, or we need to grease this, or whatever it may be. But when Dave leaves, retirement, sickness, new job, whatever the reason, that knowledge is lost. That proper in-depth experience and expertise is lost. And we don't have as much of an inflow of apprentices and up-and-coming maintainers, engineers, as we should, really. And this is a global factor. Mm-hmm. So if you have the Daves of the world, the real experience, decades and decades of expert knowledge leaving, and not enough people filling in that gap coming in, it does leave a hole that needs to be filled. And with the co-pilots, with the Gen AI functionality, it's retaining that expert knowledge forever, making it referenced forever.
And I guess, so as we come to sort of the final question, and usually there's usually two things actually. It's maybe like the final question before the final question. But so we usually finish by sort of a summary of key takeaways and things. And the other question we also ask quite commonly is, so what's next for predictive maintenance, and what's next, obviously, in the context of heavy industry? But maybe we're talking about that more collaboration. I don't want to put words into your mouth, but that seems like the way we're going. Predictive maintenance is now a team game, but not just your team here in this on this site, but a global team.
Yep.
But maybe you've got other thoughts as well.
What's next for predictive maintenance? I definitely see a change in our activities, meaning more of them. Is definitely a driver from all industries, but very much heavy industry as well, a driver to get these system solutions in place so people can start benefiting from it. But it's also in conjunction with other initiatives, OEE, energy management, digital twin. So I'm seeing a lot more cross-portfolio collaboration, so that what customers are receiving is not just one thing, predictive maintenance, which on its own is fantastic, but rather a wholesale change backed by data, backed by information which exists, so that they can make better decisions, that they can save money because budgets are tight all around. So if you can target value from multiple avenues, essentially using one data stream, really, and that's what we're doing nowadays, it has massive benefits and value on site. So that's where I see it. It's around further adoption, but collaboration with other systems like OEE, energy management, digital twin, and so on.
Yeah, and I guess you've also sort of summarized the last question I was going to ask in terms of next steps. That if there were people within these industries are thinking, actually this really does resonate with me. Predictive maintenance sounds like a great use case, and probably no doubt it's already on their radar already. They probably know about predictive maintenance, what it can do. But if they really wanted to get started with it tomorrow, John, what should they be thinking about to get in that mindset?
Think about the use case. Think about what is it that I'm wanting to achieve. If you have a downtime problem, or you're spending far too much time, money, effort, resource on planned maintenance, then predictive maintenance is a good avenue to look at. If you are having, or if you have extremely high bills due to energy, then maybe energy management is the thing to go. So essentially, look at the use case, look at what you are trying to achieve, look at where you can derive or drive value, and then the solution will follow.
Yeah, don't just think about, I want to install this or implement this new AI tool. It sounds really cool and that kind of thing. You got to think about the value it's going to bring to your business or organization.
Absolutely. Now, there are ways to get started which don't require wholesale change. We, for example, have removed the Copilot's dependency on time series data. So now we have a maintenance Copilot essential package, which works off of your data, your maintenance manuals, your user manuals, spare parts list, your expert documentation, and human feedback, the conversations, the questions. It's learning from those. So there are ways to get started which don't require wholesale change. But my bit of advice is always look at what is going to drive business value. What problems are you having? What's going to drive the value? And then the solution can come after that.
Yeah, always comes back to business value, of course. But no, for today, thank you, Jonathan, for joining us and sharing your expertise. It's been great to chat again. Hope to come back on again soon.
Thank you.
And thank you, everyone, for listening and watching wherever you are. And we'll see you on the next episode.